Hey everybody, my name is Jeff Koss and I'm going to be doing a presentation for you today called Your Turn. It's basically your turn to teach, and I'm going to go over a couple of things with you right now. So as an introduction, again, my name is Jeffrey Koss and I am a student at the University of Advancing Technology. I study robotics and embedded systems, and this is my final project for a class called DBM-100. Stands for Digital Build Materials. It's a 100 level class, and basically I was taught how to use a CAD program called Autodesk Inventor. And in this presentation I'm going to walk you through a brief history of the events that I had while in this class, and also some of the other stuff that I learned. It was a lot of fun. So let's begin. We're going to start off with the history of computer-aided design, also known as CAD. CAD got its start in the 1960s by a person by the name of Ivan Sutherland, who introduced the world to a program called Sketchpad, which was revolutionary at the time. That same year, IBM and General Motors partnered together, and they developed this thing called the DAC-1. It stands for Design Augmented by Computer, and it was released right around the same time. It was released in 1964. That program, DAC-1, was used for the rest of the century for automotive design. And the first 3D CAD program that we basically got our hands on was called ATOM, and that stood for Automated Drafting and Machining. And that was released back in 1970, and it's older than I am. So there you go. The very first item to be printed in 3D, which is quite interesting to me, was an eye wash cup. And the reason why I think that's so interesting is because it's a safety item. And you know, one of the very first things they printed was a safety item, so that must mean that they were really confident about, you know, the stuff that they were doing back then, which to me is amazing, because nowadays you'd have a lot of laws and regulations. I don't think you'd be able to do that. But moving on, I'm going to talk to you about some of the types of 3D build software. There's a lot out there now. You know, we're going to start off with the obvious, and that is Autodesk Inventor. That's the software that I was trained on just recently. It was made in 1999 by a company called Autodesk, and I'm really familiar with Autodesk products. I actually like them a lot. I've been using 3D Studio Max since the turn of the century, right around 2000. I started off with 3D Studio Max 4, and I used to use that for making models for movies and video games. The video game industry really didn't pan out for me, but the movie industry did. And that software it's targeted to small to large businesses, so it's very, very versatile. The price starts at around $2,100 a year. So, you know, it could be quite expensive for a student or somebody who's just getting into it. But it's worth it. I mean, the software does exactly what it does. It's got one caveat, though, that I have to bring up right off the bat. The software, although good, and it does its job perfectly, seems to be software that is built on top of some other software. And what I mean by that is, you'll understand this when you use it. When you're using the program, like I said, it does everything it's supposed to do. But then all of a sudden, you know, you'll have to do an extra step that shouldn't be there. Like when I finish a project, I got to hit cancel, or I got to hit accept or okay, when it really shouldn't be there. So it's almost like Autodesk took a program and wrote their own software on top of it. Now, if I would say that there's any room for improvement, it would be just that. So Autodesk, if you're listening to me out there, focus on that, because if you can fix that problem, you're going to have yourself a wonderful product. And I believe you're going to find out that a lot more people are going to be interested in it. But other than that, if you can look beyond that, it's great software. And once I start getting into this a little bit deeper, you'll understand why. But moving on, let's talk about some of the other products that are out there. There's a company in France called Dassault. They're basically an aircraft company. I'm familiar with them because I used to work in aviation. They built this program called SolidWorks, and they built it in 1993. Their target marketing was for mechanical engineers, and the price point was about $4,000 standalone license, which means that once you pay the $4,000, you own a license and you can use it for however long you want. Autodesk Inventor, you got to keep paying that every year. So I guess there's a trade-off there. SolidWorks is kind of like everybody's go-to stuff from what I understand. I have yet to use it. I haven't used it yet, but from what I understand, it's a really good program. It does what it's supposed to do, and a lot of professionals use this software on a daily basis. Now we're going to take a look at the other end of the spectrum. There's a company out there called Trimble Incorporated actually, and they have a program called SketchUp. It was made in the year 2000, and it's got a pretty unique targeting audience. They targeted it for interior designers, video game makers, and film guys, and it's pretty affordable. It's about $300 a year, and a lot of artists are used to paying that for other products. Adobe has a price point like that. They price it per month, but in the end that's about what it costs. If you're an audio engineer like me, Pro Tools is going to cost you right around that a year, and basically any standalone software around that category is also going to cost that much too. What you're paying for is you're paying for the upgrades, you're paying for the new releases and stuff like that. But if you can't afford that, there's another alternative. There's a company out there called Albury, and their product is called Albury, and it was built in 1997, and it's targeted for guys with 3D printers, indie makers, inventors and stuff like that. The price point is pretty good. It's about $150 a year, and that's standalone. That means when you buy it, you got it. I'd recommend it. I mean, if you want to get into something, cheap, start with this. It doesn't come without its problems though. When a problem does arise, it crashes, and it does it instantaneously, and it's like, where did that come from? It's pretty ambiguous when it comes to that, and that can be frustrating. But at that price point, you know what, I'm willing to deal with it. I mean, especially if it gets you into something like this, which you're not going to regret getting into. Now here's another company called TriStar, and they have a product called Creo, and that was built in 1998. See, a lot of these things were built in the late 90s, and they've been perfected ever since then. Creo was basically built for the automotive and aerospace industry. It's got a really peculiar price range, let me tell you. Anywhere from $2,200 to $20,000, and they base it off of a tier platform. So if you just want the bare bones, you pay $2,200. If you want everything, it's $20,000. All right, $20,000. Anyway, moving on. So here are some examples of some of the stuff that's been built with CAD, and I kind of grouped them in categories. We're going to start with the automotive and aerospace industry. And on the left, you see the interior of a car, a really nice interior that was beautifully done. I think it has a lot of artistic flair to it and style, and that's the reason why I chose this picture to show you. On the other hand, on the other side, you have a picture of a turbine engine. That's a cutaway, and it's basically see-through. I like this because it can give you some detail about the parts that are involved in making this, which is something that CAD can do. I mean, you can achieve this, absolutely. I just think it's a piece of beautiful work. Anyway, moving on. Interior design. We talked a little bit about that. On the left, you have basically a sketch of a room, 3D design top down, and on the right, you have the finished product done in CAD. I think it's amazing. I mean, if you're an architect or you're into interior design, pick this up. This is good stuff. I mean, look at what they've done. I mean, it's amazing. I mean, they designed a whole building. You know what else this would be good for is guys like me that like to play Dungeons and Dragons every so often. I mean, you can use this with a 3D printer and make yourself little mock-ups of the dungeons that you want to take your friends to and all that stuff. It's kind of neat, I mean, I didn't have this back in the day. We just had pen and paper. Now look what we've got. It's amazing. Moving on. So this slide is dedicated to your inventors and your makers. At UAT, at the school I go to, there's a program just for that subject. And you can make some really neat things out there. So here's two examples. You know, some crazy airplane and some little robot guy. You know, it's amazing what artists can make nowadays and bring into the real world, you know, as a viable product. I mean, this was just some cartoon sketch in somebody's mind, and now boom, you can touch it, feel it, see it, paint it, whatever you want to do. The technology is amazing. And moving on, this is probably my most favorite subject here. I'm partial to it, and I'll tell you why. CAD was actually used in a video game, called Battlezone. Battlezone was a 3D tank simulation game that you would basically pilot a tank and shoot other tanks. And it was wireframe, but it was 3D. And you had these two controllers, and if you pushed it this way, it would go that way, and if you pushed it that way, it would go this way. And you fired a button, you would shoot a tank. Right in front of you right now, I have a video of that, and I want to share that with you because it is an amazing experience. I might actually go out and find this game and buy it, because I was like 6 years old when this came out, and I just loved this game. It was amazing. Yeah, I mean, wow, look at this. A piece of nostalgia right there. I mean, by today's standards, it's probably lackluster in a lot of your minds, but to me, this was something amazing. And the experience of it, you know, it felt at the time like you were in a tank simulator. It was pretty cool, especially when you were my age, 6 years old. Anyway, moving on, because I don't want to take up too much of your time. Let's talk about what a 3D base build is. 3D base building has to do with CNC, and that stands for computer numerical control. And that is a type of automated operation of a machine by a computer. So if you can imagine a machine that's being run by a computer, that computer tells it what it needs, and that machine goes and does it. The person that is credited for inventing that is a guy by the name of John T. Parsons. In the 1940s, he made helicopter rotors, and he was basically the guy that pioneered this. There's another guy out there that worked with him, but I forget his name right now, and I apologize for that. Please, sir, if you're out there, do not hold that against me. But you know, I'm trying to keep this as short as possible. It's not going to be as short as possible, let me tell you. Anyway, a lot of different things use it: milling, plasma cutting, lathes, laser cutters, electronic discharge machines. All use CNC to make precise parts made out of precise measurements. I have some experience with it, doing boring. Boring is basically drilling holes and stuff, and I used a CNC machine to do that. And it was a pretty neat process, although a little bit messy, and having metal parts all over you, shavings and stuff like that was not my idea of a good time. But that goes with how it works. CNC is a subtractive process, and what I mean by that is that you take material away from a part in order to make it. So imagine a brick of steel, and I have a CNC machine, and I put it in there, and I press these buttons, and this safety thing comes down, and all of a sudden this drill comes out and starts drilling holes in it. It's taking material away. It's taking material out of it to make this part. So in the end, you'll have a finished part made from a solid piece of material, taken away from it, and it works. The only thing I can think of to try to explain this to you is like somebody that does woodworking and they're whittling. They have a knife and they're shaving stuff off and making a part out of it. It's the same type of process, rather than additive. An additive process is just the opposite. An additive process is like this. You're making a part by adding material to it. So examples of 3D printer. Now 3D printer, I'm going to try to explain it to you in a way that everybody can understand. Think of a cake decorator. All right, you put the frosting in the tube and you squirt it out, and you make, you write a name on a cake, or you put the frosting on it. It's the same process. You just build over it and over it, layer by layer, until finally you get a part. And that's pretty much what additive processing is. It's just the opposite of CNC. I thought I'd just throw that in there for you, because with CAD you can do that now. Everybody can go out and buy a 3D printer for $300, and start doing this. It is amazing technology, and I hope you guys get into it. So some of the careers in 3D building, there are a lot of them. Let me tell you right off the bat. I mean, I could write a Christmas list full of different jobs for this. So when you get into something like this, it's very broad. But I wrote down a couple of them so you can see and get an idea for yourself of where you're going to be at and what you're going to start doing. So a product designer is about $60,000 to $80,000 a year. A draftsman's 40 to 50 or 60,000. A design engineer is 75 to 90,000. A vehicle designer, six figures, 115 to 128,000 a year. And then you have CAD designer, which is $12 to $15 an hour, which is, you know, an average wage that you're going to be making, you know, out of high school or, you know, in a shop somewhere. It's not bad. It's a decent wage. I mean, it's not where I'd want to be at in life now, but you know, starting out, yeah, it's there. And when you start out, you're probably going to have to get a job that's a CAD designer job, you know, to get yourself into the, you know, your foot in the door and get it. But it's worth it. So you might start off making, you know, 15 an hour. Hey, that's not bad. You know, and then, you know, later on down the line, you're going to be making 100 grand. What's wrong with that? Shoot, that's where I want to be. Here's the thing about this, though. These jobs are it's so widespread that I could sit here all day and tell you the different job descriptions. But rather than do that, I'm going to kind of tie it all together and tell you the one thing that all of these jobs have in common. And that is you're going to be sitting there in front of a computer designing a part. Okay? It doesn't matter if you're a CAD designer, a vehicle designer, a draftsman, a product designer, if you work in the motion picture industry, or if you're making toys, you're going to be doing the same thing. You're going to be sitting in front of a computer making exact and precise measurements, and you're going to be pulling out a part. And that's basically what you're going to be doing. So moving on. So one of the things I wanted to do was demonstrate to you the entire process of making a part. And I did that. I'm going to show it to you in a minute. So my goal for this was to make a working prototype of a padlock that I designed myself. And the reason why I decided to go with a padlock was I wanted to make a product that was simple, as it was my first time using CAD software. But I wanted something a little bit challenging, so I felt that the difficulty would be just right. It's simple enough for a first timer and difficult enough to be challenging and a rewarding experience. Now the thing is, you know, when we get into this stuff, you got to do your research, you know. And so what I did is I started off by looking at some of the successful designs of padlocks. I went through a lot of stuff, you know, master lock, you know, pictures of all these things, pictures of people that did 3D locks, you know, made their own and stuff like that. And I finally settled on a simple idea, but it was effective and it stuck in my head, and that was the design that I went with. And my philosophy and my process with that is, like the film industry, you have to study the classics in order to get good at what you do, and then you can proceed from there. So a padlock's been out for centuries, and the design is very simple. So I figured that would be the closest way for me to be able to study the classics. And I'm not sorry for doing it. I mean, I made it. It works. It's cool. But you have to understand something. I'm not an artist that can draw. I can't draw complex ideas on paper, but I'd like to. So I think I'm going to try that. I think I'm going to try learning that. Anyway, I decided to give it a go. Don't laugh at my drawings, because I'll be mad, but don't laugh at them, because here they are. So here are my here are my concept drawings. Yeah. All right. So on the left-hand side, you have basically a mechanism that will turn when you put the key in, and you have my sorry-looking key. Then you have the shackle that opens, you know, the lock that opens, a tongue and spring that works for the mechanism inside the lock to make it, you know, open and close. And then you have the back of the lock and the top and front of the lock of itself. You probably can't make heads or tails out of it, but I can. I know what I was doing, and I know what was in my head. So I gave it my best shot, and that's what I came up with. Don't laugh, because what you see next, you're going to be amazed with. And I'll show you. So the next step was to make my drawing go into a program called Autodesk Inventor. That's what we were being, you know, taught with. So I started by making a sketch, and a sketch is just that. It's a 2D drawing of your part, and it's pretty neat because Inventor has all of these little bells and whistles you can use, right? I wanted to draw a line, I click that, draw a line. If I want to draw a circle, I click that and I draw a circle. And then you can give it dimensions. You click on dimension and you can actually give it precise dimensions. In the end, you're going to have this 2D drawing. Okay? And then what you do from that is, after you have that 2D drawing made, you can extrude it. So in other words, you can add material. You can pull that part out into 3D space. All right? And start making it into something really viable. And that's where the magic happens. So you extrude it, you know, you can do all of these different manipulations to this part. And then the next thing you know, you have a 3D part in your hands. It's that simple. It's that amazing. So I'm going to show you. So here are some of the designs that I came up with this lock. That's the base of the lock on the left. There's your mechanisms in the middle, and then you have the shackle, the locking piece that is on the right. It sure looks like parts to a lock to me, if you ask me. And it works like a lock, so if it works like a lock and it looks like a lock, that's probably a lock, right? Right. Okay, moving on. So after I made each individual part, in Inventor, you have different things that you can do. You can make individual parts, you can make assemblies, you can make drawings, and you can make presentations. So my next part in this was to make detailed drawings on every single piece that I made for this part. Autodesk makes it so easy to do. It's amazing. A couple of clicks and you have a detailed drawing that you can take to any shop and have your part made. No joke. I'm not even kidding about this. You take the base part, you put it down, you click, then it transfers to another part. You click again. There's another part. You click again and it's finished. It's that simple. It's almost idiot proof. It really is. Man, they did a really good job with this. And here it is, right here. So this is the back part of my lock. Now you could probably get more detail into it, you know, if you wanted to, but for all intents and purposes, for a software program, just picking this up, it's amazing. It's simply amazing. I mean, wow. I love it. That's all I can say. And it works good. I mean, it's not screwed up, I'll tell you that. Okay, so the next step is the assembly of the padlock. So basically what you have to do is you take all of the individual parts that you make, called parts files, and you import them into another file. Okay, and that is called the assembly file. So I had like 5 or 6 parts. I imported them all and I arranged them, I put them together, and it looks like a lock. So you can add what they call constraints to it. And what a constraint does is it limits the movement of that part into certain directions, or prohibits or allows it to do certain things related to physics. So you can make this product behave exactly like it should in the real world by applying these constraints, and it acts on the principles of physics, and you get a product that works, feels, looks, and does exactly what it's supposed to do in the real world. And Inventor is pretty good at doing it. I can't praise it enough. The constraints help me visualize how the part would work as a 3D printed part. And there it is. Don't make fun of my key. I'm not an artist, and it's supposed to be a key, but it doesn't really look like a key, but it is a key. Anyway, so that's my part put together. All right, and as you can see, it fit right together. It's great. One of the things I will tell you though is I couldn't make exact measurements. I didn't have calipers on me, or I didn't even have a tape measure on me. So I did this all by eye. I came pretty close, but it's not perfect. You know, I mean, you can get it perfect if you do have the right tools. Let's just put it to you that way. So the next step, and basically the final step in your CAD process, is you want to make a presentation so people can see what your part's about. What does it do? How is it made? So you can make a presentation and put it into a video, and you can show how the part works, or you can do what we call like an exploded view, where all the parts of the part come together and make the part, or vice versa. You could take the part apart and make the parts fly out of it. And that's what I do in the next slide. But I will tell you this, Inventor made it really easy. I mean, the thing about Inventor is it's easy. How easy? Anybody can do it for real. It's that easy. a few clicks and a few adjustments, and I had a working presentation. I put it on YouTube. I'll show you it. Here it is right here. Okay, so voila, there it is. So as you can see, the parts are coming out. I mean, there's parts that are hidden that you wouldn't even know are there until they come out and you see it. I probably would have sped this up though. It does take a minute, and I guess it's kind of distracting, but hey, it was my first attempt at it, and you know what? I think I did a pretty good job, so I'm happy with it. And in the end, yeah, you can really do some fancy stuff with this if you know what you're doing, but as for me, being a first-time user, this is what I came up with, and for first-time user, not bad. Okay, so in conclusion, we're going to conclude this now. In conclusion, I learned the entire process of how to make a CAD project from start to finish. I really did. I went from a concept drawing to sketching it out in this program to pulling the part out and making it a viable part. I did that several times to make several different parts. I combined those parts into an assembly and put some restraints on it to make it work like the actual part should work. Okay, and at that point, I mean, you can go ahead and print that part out, you know, with any 3D printer. Autodesk has the ability for you to be able to export in a lot of different formats, and there's one there for your 3D printer. Let me tell you, it's there. You can make a parts drawing. You can make, you know, a technical drawing that you can take to a shop and give it to them, and they can make the part for you. You can do a presentation now, you know, with that, and make a movie and show everybody your great new thing that you made. I have learned this all in this class, and I'm pretty good at it now, I think. There are some things that I would do differently. For instance, like I said, I would definitely make better precise measurements in my parts. I would use calipers and stuff like that, because if I'm going to get into this, I would definitely do it the right way and do it precise. CAD is all about being precise. It's not a 3D solid modeling program like 3D Studio Max for artists. It's for the technically minded and savvy person who wants to make a viable part and bring it into this world. That's what this is for. Like I said, some of my parts didn't fit perfectly, and I'm a perfectionist. I was a little disappointed about that, but that was on me and not the program. I would also learn some basic drawing skills. I don't think it's going to hurt, but don't let that discourage you. If you want to get into this, pick up the program and start working with it. You can get what's in your mind in this really easily. Once you know the software, once you know how it works, you'll be able to do some amazing things with it. Do you need to learn how to draw to use this? No. Not on your own, not for the stuff that you want to do. But if you're going to get into this professionally, get hired into a place, I would definitely suggest learning how to draw some things. I am going to be using this as a solid foundation on how to build objects for robotics and embedded systems. And I plan to use this from now on to create prototypes of the projects that I'll be working on. And believe me when I say this, I'm going to be using this a lot. This is one of those programs that, you know, you pick it up and you want to make something, you know, 3 months down the line, okay, I got an idea, you can come back to it. It's not that hard. It's not that hard to remember. You know, it's pretty much, it's once you know what you're doing, you'll get it. It's like riding a bike. You're not going to forget it. And in the end, I feel accomplished because I learned a lot in a short amount of time, and I'm going to continue to practice my skills and develop new projects. Now here's the thing. I learned all of this in an online class in 5 weeks, okay? I learned how to go from start to finish within 5 weeks and have a presentation ready. Now it's not perfect by any means. No, it's my first time doing it. But as a first-time user, I'm really impressed with the amount of information that I was able to obtain from this, and I have it for the rest of my life. Can I make a part now? Yeah. Can I make, you know, wonderful things? Absolutely. So I'm impressed with it, and I hope you are too. And if you're impressed with this, give me an A. I really appreciate it. And thank you, and have a great day.